Hello and welcome to the WindowsSCOPE Student Series tutorial on 32-bit virtual memory management. Virtual memory is a type of memory management that uses a secondary memory storage device such as a hard drive to simulate main memory. It also gives each process a unique memory space which conceals the existence of other processes. This stops applications from interfering with each other's memory unintentionally. In a 32-bit machine such as this one, the total memory addressable by one process is 4 gigabytes. In a Windows 32-bit process, the top half is reserved for system memory, while the bottom half is allocated to the process. This means that a process actually only has 2 gigabytes of memory available for its own use. To illustrate this in WindowsSCOPE, we can look at a driver. If we examine the topmost bit of the address, we will see that the address is in the top half of memory. This is because Windows drivers run in the kernel's memory space. If we look at code from the Processes folder, we see the addresses are in the bottom half of memory. If we navigate to the Investigate tab, while some code is selected under the Structure Map tab, we can see the raw bytes of the module. Now we can disassemble this code and then click the Highlight button. The addresses that were in physical memory at the time of snapshot are highlighted in green. This means that the valid bit is set in the page table entry for this page. The data in white was not present in physical memory before the fetch, but was still in virtual memory. This means that when the fetch was started, the data had not been paged in from the disk. To see the page table entry for any instruction in physical memory, right-click and press Look Up Page Table Entry. Here we are able to see every bit in the entry and what they mean. These first bits are the page frame number, which is the physical address for this page. The No Execute bit is a feature that can be seen in Physical Address Extension, also known as PAE systems, and indicates whether bytes within this page are marked as executable code or storage data. This bit is set if there is an 8 here. This helps to prevent buffer overflow attacks where malicious code injects instructions into a data buffer and then attempts to execute those instructions. With the No Execute bit set, the processor will not be able to execute instructions that an attacker has injected into data memory. PAE is a feature that extends addresses to 36 bits on 32-bit systems, allowing up to 64 gigabytes of addressable memory. The Prototype bit tells us if this entry is a prototype, meaning it is used to describe shared memory between multiple processes. The Copy on Write bit lets us know if the page can use copy on write, which is a method of conserving physical memory. The Global bit is set if the translation applies to all processes, meaning this address is always ready to be translated. The Large Page bit signals that the page directory entry maps a 4 megabyte page, or a 2 megabyte page on non-PAE systems, instead of the standard 4 kilobyte page. The Dirty bit is used to see if the page has been written to. The Accessed bit tells us if the page has been read. The Cache Disabled bit identifies if caching has been disabled. The Write-Through bit makes it so that changes to this page are immediately written to disk. The Owner bit indicates whether the page can be accessed by user mode. The Write bit tells us if this page is read-only. Finally, the Valid bit is the most important bit to see through WindowsSCOPE. It shows us whether the page is in physical memory or not. Here on the left, you will see the page table with a page table entry highlighted. The memory manager is able to keep track of the entire memory space through use of these paging structures. The table is always kept in physical memory so that virtual addresses can be looked up. This node is organized in a hierarchy of drop-down boxes. For PAE systems, the top-level node is a list of page directory pointers by process name. When the page directory is selected, the next level down is a list of page directories, of which each process has 4, numbered 0 to 3. For non-PAE systems, the top level is a list of page directories by process name. Once a page directory is selected for either type of system, the next level down in the hierarchy is a list of page tables, numbered 0 to 511 for PAE systems, and 0 to 1023 for non-PAE systems. The next level after that is a list of 64 entry ranges of page table entries. In the Configure View tab, there is an option to show or hide the page table entries that aren't marked as valid. This concludes the introduction to the Windows 32-bit Virtual Memory Management tutorial through the use of WindowsSCOPE. Thank you for watching, and please be sure to view our other tutorials.